information across that. And so we're really looking at now, how do I implement a solution that allows them to accomplish this without exposing either domain 1 or domain 2 to unauthorized access. The worst possible way is just to connect the networks together, because that allows everybody in domain 2 to access the information in domain 1 and vice versa. And so that really is giving too much access. So this is a complicated problem. And so when we really look at linking together some of these functions and sharing information, we have to think about what is the business model that I'm trying to satisfy. So we're really looking at the functions. And within each of these domains, we have to think beyond just the TCP/IP networking layer. We have to look at what is the functions that are being done. What plans are being done. I can think of each domain as a machine. The machine has a plan that it's implementing, a set of processes, a set of databases, and a set of people. I can't forget the people that are part of that domain. So together that comprises the business model of domain 1, and I have the same thing for domain 2. So I'm looking at which processes need to talk together, what databases or what portions of the databases need to be shared, and then which respective users in each of those domains need to access that. And then the degree to which the plans or the objectives of domain 1 and the plans and objectives of domain 2, what do they have in common? What do they have differences? For example, if these are two companies and they're engaged in a joint venture, which is a complicated type of transaction, they have areas of mutual interest, but then they also have competing interests. So in coming up with my design for that system, I really need to separate those two things, because you don't want to compromise the areas where they need to share, and I also don't want to compromise the areas where they don't need to share. And so to do that, we have to think about the different parts of the problem. And one part of the problem is, of course, the things that happen within each of the local domains. The other part of it is what happens in the interconnecting system. And the interconnecting system can be a VPN between the systems. It could be the internet. It could be an SSL session. It could be a variety of ways in which we communicate between the two domains. And we have to distinguish the security policies that apply to each one of these three different things. Now, I'm showing a case of two different domains. If I have more than that, you can see that the problem becomes more complicated, because you have a factorial mathematics at work here. And so you could very quickly end up with combinations of things that would overwhelm a simple enclave architecture. You can't just implement this in a set of firewall rules. You really need to think through the design of how to implement that. The other point is I have to actually look where I transfer responsibility from local domain 1 to the interconnection system, and then from the interconnection system back to domain 2. So the transfer points are places where I have to pay particular attention to how I hand that responsibility off. And so those are all part of coming up with an effective design. So when we look at a cross-domain model, this diagram is really a nice, simple way to think about it and make it something that is easy to build. I can distinguish different parts of that system. The user, his workstation, the network in domain 1, the servers in domain 1, and then my boundary systems like the firewalls that are part of providing and brokering that interconnection. You think back to that list of security requirements. For example, there's one for maybe screen lock. Screen lock is an obvious security requirement. If, let's say you're a bank and you have a teller at the bank and she's at her terminal, if she walks away, anyone can come and conduct transactions as if they were her. With screen lock, that console is locked, and so that system is protected by a password that has to be re-entered when that session is resumed. It's the same thing if it's a doctor at a medical center, in terms of protecting the private type of information. There's only one logical place to do screen lock. It's not the firewall. The only logical place is the workstation. So if I go back to my original list of requirements, whether it was confidentiality, integrity, availability, I can put all of those on little cards. And I should be able to stick that card on some picture of where it's being done in my system. And if I'm careful about where I do that, I don't end up imposing a requirement on a device that can't do it. I don't want to try to do screen lock on a switch or a firewall. It doesn't make sense. The only logical place to do that particular requirement is on the workstation. Separation of roles. We talked about separating the security administrator from the system administrator. The only place I can do that requirement is at the user level in terms of the rights and privileges I grant to users. I can't implement that anywhere else. So if you think through your requirements, you can easily map them into the logical component to implement that, and now you have something that makes sense in terms of an integrated system. Okay, now if we have a more complicated system and we look at multiple domains sharing information, I have multiple boundaries. So if I think about my enclave architecture again, I have different boundaries. I have 3 different enclaves in this picture, but then I also have the overall integrated system. So we're really looking at where are my trusted users, where is my trusted information, and where are my untrusted applications. So to make it more complicated, let me talk a little bit more about this thing called web services. And some of the other terms that you'll see are things called SOAs, service-oriented architectures, or sometimes you'll see things called net-centric systems or net-centricity, where you're really talking about linking together the systems. This is a busy chart. Don't worry about reading it. But what we're really looking at is the way we use the internet is changing. And we have seen, even within a fairly short period of time, major changes in the way we use the internet. From the original command line type of interactions with hypertext that were just textual links to the graphical browser, which really popularized the internet because it was point and click type of functionality. And when the graphical browser first came out, people had to keep their homepage or some list of links because there wasn't any way to find out where things were. And so you ended up having to type in a URL. Most people don't type in URLs anymore because they have other ways to find things. But back in the early graphical browser, you had to know the list. So what became very popular early on to fill that need were portals. People would go to portals like Yahoo or to other places that would be lists of links. And those very quickly evolved into search engines, which provided more of a dynamic way to keep up with the internet and in terms of the changes. And today, a lot of activities still are done by going to Google and typing in what you're looking for. If you're looking for CERIAS, instead of trying to figure out what the URL is for the CERIAS webpage, you just go into Google and type CERIAS, click return, and bing, up at the top, and you click it, and there you go. And you're trusting the search engine to get you to the service that you're looking for. Well, with web services, that model changes now. And with the XML protocols, you have a different way of connecting things that you don't have to go and search for things anymore. Within this architecture, services register themselves, whether they're data sources or applications that are available on the internet. You basically, the process becomes more transparent to the user and easier to function. And that's becoming very popular. The one that is in widespread use now is the RSS protocol, which is really a very simple model for a push type technology. But the whole series of XML protocols really provide a standards-based way of implementing services-oriented architectures, where part of a program can run on one system, another part of the program can run somewhere else on the internet, they can exchange information. And so we're really looking at this as the way of building those kinds of applications that can share information